Hello dear students, I welcome you all to another session of online class on Set Theory Class 11 Mathematics. So the topic for the day is Algebra of Sets. So basically there are certain rules that two or more than two sets follow, and these are those rules. Now talking about their proofs, you will find the proof of all these in your textbook, alright. So in fact, in any textbook you will be able to find these proofs, but for your understanding I am going to take only few very important ones to make sure that you understand the other proofs as well from book. Okay, so let me take the first one. So first one says, the name of the first law is called Idempotent Law, and in this what we do is we will take one set, for example A, and we'll take the union of that set with itself and the intersection of that set with itself. So A union A will be A itself and A intersection A will be A itself. Alright. Next is identity. So identity means something is given, okay, something is given, some set is given, and after doing something to that, after taking union or intersection, its identity should not change. That means if it is A, after that also it should remain A. Alright. So if you take union of A with empty set, then its identity will remain as it is. It will remain A itself. Now if you take intersection of any set A with its universal set, then also you will get A. That means the identity will remain the same if you take intersection with universal set. Okay, so next is called boundedness laws. So in boundedness law we will have the same kind of thing. All right, so I'm sorry, here if you take the union of any set with its, see here in identity laws we have taken union with phi. Now in boundedness what we do is we will take union with universal set, and the union with universal set gives you the universal set itself. Alright. Now in earlier case you took intersection with universal set, this time you will take intersection with the empty set. So intersection with empty set will remain empty. Alright, fine. Now the fourth law, we don't have any name for it, but you need to remember is A, any set A can be called as the subset of A union B, okay, and A intersection B will be the subset of A. So if you want to understand this, or if you want to remember this, what you can do is you just remember the Venn diagram. Alright, so this is my A, this is my B, so this is my A union B. So this is how the A union B looks. Now clearly we know that A is a part of A union B, isn't it? So that's why you can say that A is a subset of A union B. Alright. Now what is A intersection B here? So A intersection B will be this part, isn't it? So this is your A intersection B. Now this A intersection B is a part of A, isn't it? So that's why A intersection B is a subset of A. That's what is being said out here according to this law. Alright. So we have next one is this one. So here also we don't have any name given, but what is given is A is a subset of B, means if you put union C both side, still the sign will remain same. That means it will be the subset. Similarly same thing happens if you take intersection of same sets both sides. All right, okay. So next is complementation law. So basically we are going to see only complements out here. For example, if you take complement of universal set, then you will get empty set. Okay, the complement of empty set will be universal set. Complement of complement will be the set itself. Okay, A union with A dash will give you universal set, and at last we have A intersection with its complement will give you the empty set. Okay, so these are the laws whose proofs need not be done, but these are the very important ones for us, and we need to learn how to prove these laws as well. Alright, so we have commutative law. So commutative law says just reverse the order. A union B will be equals to B union A. Alright, next is A intersection B will be equals to B intersection A. Now associative. So in associative we have 3 sets. Alright, so what are the 3 sets? 3 sets are A, B and C. Now choose any two. For example, A and B, take their union, and after that whatever you get, take the union of that set with C. The same thing will happen, or the same value or the same set you will get if you first take the union of B and C, and whatever result you get, take the union of that with A. Alright, so this is called your associative law. So same thing goes with your intersection as well. Now this is very important for us. This is called distributive law. You are going to distribute here, right? Okay, so here A union with B intersection C. Now we will distribute union out here. So if you distribute this union with B, then you will get A union B. So we have in the middle intersection. So intersection will come here, and you have to distribute this union to C now. So we get A union C. Okay. So this is called, this first one is called distribution of what? What have you distributed out here? You have distributed union. Remember that. So this is called distribution of union to intersection. Alright. Similarly, the same thing goes here, and this is called distribution of intersection to union. Alright. Fine. So next is very important again. This is called De Morgan's law, which we have already seen, isn't it? So the same thing you will come across in your one of the very important chapter, mathematical reasoning as well. Alright. So this is called your De Morgan's law, where you will deal with again complementation. So next is this one. This also we have actually seen in one of the exercises. So next is this one. Okay. So here we are proving, or we have 2 ways. Okay, implies and implied by. This is called implies and implied by. So A intersection B equals to A is implies and implied by A is a subset of B. So what are the meaning of this? We will try to understand using the proofs only. Alright, and we have got altogether 14 properties. So pause the video and note down all the properties. So let's take the proof of associative law. So I am taking one associative law, the other one you can either refer to your book or you can try by yourself. It will be better if you can try by yourself. So here we need to show that this is equals to this. Now one thing that you need to remember is, here this represents a set, isn't it? And this is also set, right? Okay, so basically you are showing that there are 2 sets which are equal to each other. Alright, so what is the strategy? That's what I am going to show here. So if I show that A is a subset of B, that means every element of A is an element of B. And next one is, if I show that B is a subset of A, that means every element of B is a subset of A, then using these two, what I can say here is, I can say that A is equals to B. Same thing happens with number also. For example, if x is greater than or equals to y and x is less than or equals to y, what does this imply? This implies that x is equals to y, isn't it? Alright, so our strategy here will be, in order to show that the 2 sets are equal, we will show that one is A is a subset of B, and we will show other one, that is B is a subset of A. This is how we show that 2 sets are equal. Alright, so basically here also what is happening is, we are taking number 1, that is A union B union with C is equals to A union with B union C. So this is one set, this is another set. If you call this as A and this as B, then A is equals to B. That's what you want to show. Okay, so to prove this, we'll show that this is a subset of this. Okay, now let's try to understand this. A is a subset of B. What is the meaning of this? If you choose any element from here, then that element belongs to this, isn't it? Or that element is a part of this. That's what is the meaning of this, right? So that's why if I choose any random element from here, for example x, and if I take, see, I have taken x is belonging to A. I am taking x from A, and if I am able to show that this x also belongs to B, that means every element of A belongs to B. So this means A is a subset of B, right? So same thing I am going to do here as well. Alright, so let x belong to this. Now I am showing this is a subset of this. Okay, so let x belongs to A union B union C. B chosen randomly, you can write that also, or we write arbitrarily chosen. So this will be the appropriate language. So x is chosen randomly from here. Okay, so it can be any element. Now see here what is happening. If x is belonging to the union of this, what is the meaning of this? This means that, see, if this is my A, then this becomes like x belongs to A union C. Are you understanding this? X belongs to A union B. Suppose if this is the case, then what does it mean this? This means that x belongs to A, right? But what if x doesn't belong to this? If x doesn't belong to this, then x must come from B, isn't it? Because if x belongs to A union B, for example, I will show you using this one. So suppose A union B is 1 2 3 4, A is 1 2, B is 2 3 4. All right, so what have I done? I have chosen any one element from here. For example, 1. Okay, choose any element from A union. For example, 1. If I choose 1, then this 1 belongs to A. Yes, but if I don't choose 1, for example, if I choose 4, then 4 doesn't belong to A, but 4 belongs to B, isn't it? So that's why if you choose any element from A union B, this means that this A should come from A or this x should come from B. Alright, so that's what will be done here. So we have x belongs to this union C, means x belongs to this A union B, or x belongs to C. Alright, so forget about this. Now this is also similar condition, right? So this means that x belongs to A or x belongs to B. Now we have or x belongs to C as well. Yes. Now if I combine these two, this means if x belongs to B or x belongs to C, this means x belongs to B union C as well, isn't it? If x belongs to B or if x belongs to C, then this x will definitely belong to B union C, their union, isn't it? So now this or also represents again union, isn't it? So we have x belongs to A, or means union, we have B union C. Now see here, I took this to be my x, for example, and this to be y. So x equals to y, that's what I wanted to show, and I choose one random element x from this, that is x. And after that I showed that the very same x belongs to this, that is y, isn't it? So this means what? This means that x is a subset of y. Any element of x is belonging to this as well, isn't it? So this means that x is a subset of y, that is A union B union C is a subset of A union B union C. So this is the first part. Now second part is we have to show that y is a subset of x, isn't it? Now for that I have to choose one random element from here. So let y belongs to A union B union C. Alright. Now this means y belongs to A or y belongs to B union C. Alright. So this means y belongs to A is already there, or this means y belongs to B, or y, this means or y belongs to C. right? Now again, if you combine these two, you have y belongs to A union B or y belongs to C. Now what's the meaning of this? This means that y belongs to this, or if you convert this into union, then this can be written as A union B union with C. Okay, so this was my y and this is my x. See, I chose random element from y and I got that the same element is a part of x as well. Now what is the meaning of this? This means that, okay, I don't have space here, let me write here. So this means after therefore you'll write therefore this, that is A union B union C is a subset of x, that is A union B union with C. Okay, so if you call this as, for example, if you call this as 1 and this as 2, so you will write using 1 and 2, using 1 and 2, that is this and this, you can write A union B union with C will be equals to A union with B union C. So that's what we wanted to show out here. So pause the video and note it down. Now let's see one of the proof of distributive law. So we have got two distributive laws. So I'm taking number 2, second distributive law. So again, this is one of the set and this is another set. Call this as x and call this as y. Okay, so x equals to y, that's what we need to show here. And to show that, what we are going to do is we will show that x is a subset of y and y is also a subset of x. Okay, so let me take any element from this. I am showing x is a subset of y. Okay, so let x belongs to A intersection B union y be arbitrarily chosen. Okay, so remember, this means and this means or. Intersection means and, union means or. So this means that x belongs to A and x belongs to B union C. Okay, now we have x belongs to A and see, x is present there within A. Alright, now this x must either come from B or C. Alright, so x belongs to B or x belongs to C. Alright, see, x is already present in A. Okay, no matter whatever is your condition, but x is always there in A. So x can be either there in B or x can be there in C. Alright, so this means that x is always there in A and x is belonging to B. Now if x is not belonging to the B, then we must have or x is already belonging to A, and if x is not there in B, then this x has to be there in C. Alright, so if this happens, that's very good, but if this doesn't happen, that's why I have written or this happens. Alright, now what's the meaning of this? If x is belonging to A and B both, this means that x belongs to what? A intersection B, isn't it? Because there is and, so that's why I have written and. Or this means x belongs to A intersection C. Right? Now if x belongs to this or x belongs to this, suppose this is my x, this is my y, x belongs to x or x belongs to y means x must belongs to their union as well, isn't it? So x belongs to A intersection B union with A intersection C. See, starting in this was x, I took any random element from x and I showed that that random element also belongs to y. So therefore this means that this is the subset of this, that is A intersection with B union C is a subset of A intersection B union with A intersection C. So call this as equation 1. Now we need to show that y is a subset of x. So in order to show that, I'll choose one random element from y. Okay, so let y be chosen from A intersection B union with A intersection C be arbitrarily chosen. Okay, so this means that y belongs to x union y, means y belongs to this or y belongs to this. Alright, so y belongs to A intersection B or y belongs to A intersection C. Now if y belongs to A intersection B, then this means y belongs to A and y belongs to B, isn't it? Yes? Or this means y belonging to A intersection B means y belongs to A and y belongs to C. Alright. So from this, let's see what is happening. Here y belongs to A, here also y belongs to A. So in both the conditions we have y belongs to A. So this means y belongs to A is always true. Okay. And here y belongs to B, here y belongs to C. So there is a choice. Alright. So that's why I am writing here or. This is a choice, so that's why I have written or. So or y belongs to, so y belongs to A, that is already happening, and along with that y must be coming from B, so that's why I have written and here. So y must be coming from B or y must be coming from C. Alright, so this means y belongs to A and now what is the meaning of this? This means that y belongs to B or means union C, isn't it? So if you combine this two, this is also set, this is also set. So y is belonging to this set and y is belonging to this set as well. So if y belongs to these two sets, then y definitely belongs to their intersection as well. Yes? So this means y belongs to A intersection with B union C. Now see, I chose random element y, random element from y, and I showed that the very same random element is also a part of x, isn't it? So this means that this is a subset of this. So A intersection B union with A intersection C is a subset of A intersection with B union C. So let me call this as equation 2. Alright. So if you see, using 1 and 2, okay, so using 1 and 2, we have A intersection with B union C will be equals to A intersection B union A intersection C. So that's what we need to prove here. So pause the video and note it down. Now let's take the proof of first De Morgan's law. Again, this is one of the set and this is one of the set. Okay, so here since we are dealing with complementation, so we need to understand this. If x belongs to A, okay, for example, A dash, if this is my A, then A dash will be this, isn't it? So if you choose any x from A dash, this is my A dash. So what's the meaning of this? If x belongs to A dash, this means that x do not belong to A. See, x is coming from this, no? So x does not belong to A. So that's what is the meaning of this. So you need to understand here. So again here I need to show that this is my x and this is my y. So x equals to y. So strategy is I need to show that this is the subset of this and this is the subset of this. So let's show that this is the subset of this. So to show that I need to choose one random element from here. Alright, so let x belongs to A union B complement. Now if this happens, now what is the meaning of this? This means that x do not belong to A union B. Alright, x belongs to A means x do not belong to A. So that's why x belongs to A union B complement means x do not belong to this. Okay, now what is the meaning of this? This means that x does not belong to A. here be careful, you might see that this is a union and you will write or. Okay, so that can be done only if there is belong to sign. Okay, if there is not belong to sign, then this union becomes and, okay, and intersection becomes or. Remember that, alright. So does not belong to A and X do not belong to B as well. Yes, X do not belong to A, X do not belong to B. So that's why X do not belong to their union as well, in simple words. Alright, if X belongs to B, then what happens? Then X belongs to their union, isn't it? Okay, so that's what is the meaning of this. Now, X do not belong to A means what? If X do not belong to A, then X belongs to its complement. Yes, so X belongs to A complement and X belongs to B complement. Now there is belongs to sign, so that's why this and becomes intersection. Alright, so X belongs to A dash intersection B dash. Alright, see, I chose random element from here and I showed that that random element is a part of this as well, isn't it? So this means that A union B complement is a subset of A complement intersection B complement. So this is my first part. Okay, so let's see the second part. So in the second part, what we need to show is this is a subset of this. That means I need to choose one random element from Y, that is this. So let Y belongs to this, that is A intersection A dash intersection B dash. So what's the meaning of this? This means that Y belongs to A dash and this means and Y belongs to B dash as well. Now what's the meaning of this? This means that Y do not belong to A, yes, and Y do not belong to B. Now as I said earlier, if this sign is there, do not belong to, then this and represents union. Alright, so this means that Y do not belongs to A union B. Now what is the meaning of this? If Y do not belong to A union B, then Y must belong to its complement. That's why A union B complement should be written here. Okay, so see, I started with this, I landed up here. So this means that this is a subset of this. So we have A dash intersection B dash is a subset of A union B dash. Alright, so let me call this as equation 2. So again, from 1 and 2, we show that A union B complement will be A complement intersection with B complement. So this is your De Morgan's law. Pause the video and note it down. Okay, so the next property that we need to prove here is property number 11, which says A minus B is equals to A intersection B dash. Now let's see what is the Venn diagram for A minus B. So this is my A, this is my B. So A minus B means elements of A which are not in B. Yes, so this is your Venn diagram for A minus B. So for example, if I choose any element from here, this element belongs to A but do not belong to B, isn't it? So that's why to show that this set is equal to this, again the strategy is same. I am choosing one random element from here. So let X belongs to A minus B. Now if X belongs to A minus B, this means that X belongs to A and X do not belong to B, isn't it? Yes, X belongs to A and X do not belong to B, right? So this means that X belongs to A and X belongs to, if X do not belong to B, then X belongs to B complement, isn't it? So if you combine using, see, both has belongs to, so that's why this and becomes your intersection. So X belongs to A intersection B dash. So I started with this, landed up here. So this means that A minus B is a subset of A intersection B dash. So call this as equation 1. Now let us take one random element from here. So let Y belongs to A intersection B dash. So B arbitrarily chosen. We have to write that as well. B arbitrarily chosen. Okay, so this means that y belongs to A and y belongs to B dash, isn't it? Now this means that y belongs to A and y do not belongs to B, isn't it? Because y belongs to B dash, so that's why y do not belong to B. So this means that y belongs to A minus B. I started with this, landed up here. So therefore A intersection B dash is a subset of A minus B. Call this as 2. So using 1 and 2, from 1 and 2 we have showed that A minus B is equals to A intersection with B dash. Pause the video and note it down. Now let me take question number or property number 12, which says that this happens. Okay, so here we have two arrows. So basically this means we need to prove that, so there are two parts as I said. To number 1 is, okay, so A intersection B equals to A implies A is a subset of B. So this is the first part, and second part is we have to show that A is a subset of B implies A intersection with B is equals to A. So these are the two parts. Alright, so if you compare this with your if then statement which you have learned in your mathematical reasoning, this is your P. So P implies Q. Now what is the meaning of P implies Q? I am showing first part. Alright, so what is the meaning of P implies Q? P implies Q means P is given, right? So that's why in the first case given is what? Given is A intersection B is equals to A. Now if this is given, then we need to prove Q, isn't it? So we need to prove that A is a subset of B. Now what is the meaning of A is a subset of B? It means that any element of A is a part of B, right? So that's why I need to choose one random element from here, and if I show that that particular random element is also a part of B, then we are done. Okay, so let X belongs to A be arbitrarily chosen. I have chosen it randomly. Now if X belongs to A, we know that A is A intersection B, isn't it? So this means that X belongs to A intersection B as well. Why? Because A can be written as A intersection B. Okay, now if X is an element which is common to A and B, common, right? Intersection means common. So then this means that X is also a part of B, isn't it? Now see here, started with X belongs to A, which was random, and I showed that this X is a part of B as well. So therefore A is a subset of B. So we are done with the first part. We have proved this part. Alright. Now we need to prove the second part. Okay, so in the second part this becomes my P and this becomes my Q. So this means that P implies Q means that P is given, right? So given is A is a subset of B, right? Now to prove this we need to show two things, right? One is A intersection B is a subset of A, yes, and next is A is a subset of A intersection B. So if I am able to show these two, then we are done. Now one thing that we already know is this one, yes. So if you see algebra of sets which you have noted down in the beginning, there you see that this property is already written, yes. So we know that A intersection B is a subset of A is already true. So let me call this as equation 1. Okay, now next is we need to prove second part. So to prove second part, I am going to choose one random element from A. Okay, so let X belongs to A be arbitrarily chosen. Okay, now if this X belongs to A, see here, if this X belongs to A, then X should belong to B also, because it is given that A is a subset of B. That means every element of A must belong to B as well, yes. So this means that X belongs to B as well, isn't it? Now since you will write A is a subset of B as well. Okay, now X belongs to A as well and X belongs to B as well. So this means X belongs to A and X belongs to B. Yes, now what is the meaning of this? This means that X belongs to A and B. Yes, so we can say that therefore A is a subset of A intersection B. So we have showed this part as well. So let me call this as equation 2. So using 1 and 2, we showed that this happens, isn't it? So we have A intersection B is equals to A. So pause the video and note it down. Okay, so the 13th property says that A minus B equals to phi, that is empty set implies and implied by A is a subset of B. Again, there are two parts to be proved, so we need to yes, so there are two parts to be proved here. So let us begin with the first part. Okay, so it is given that A minus B, or you can write this as, because we know that A minus B can be written as A intersection B dash equals to phi. So in this case, what is given? It is given that this is happening. Yes. Okay, so given is A minus B equals to phi. That is, what is this? Actually, this is A intersection B dash is equals to phi. Alright, now what we need to prove is, if this is given to you, we need to prove this, isn't it? So we have this happens using identity property, isn't it? So using identity property, we know this. Now what am I going to do is, I am going to write this universal set as the union of B and B dash. This is also possible, yes, so we know this as well. Now we have, see, you can check all this in one of those properties, alright. So you have noted down 14 properties, so there only you will find that B union B dash can be written as universal set. Okay, so let me apply distributive property here. So if I apply distributive property, then this becomes A intersection B union with A intersection B dash. Alright, now what is this? This is A equals to A intersection B union with, now what is this? This is equals to phi, isn't it? Now the union of any set with its empty set will be how much? It will be equals to A union, A intersection B itself, using what? Using identity property. If this is my A union phi will be A itself. Alright. So this is what we got. Now one more property is there which says, also we know that A intersection B can be written as subset of any this set, isn't it? Or you can write A also, but I need B. Why? You will understand here. Okay, so we know that A intersection B is what? It is A, right? So that's why instead of this I am writing A. So that's why A is a subset of B. So this is what we need to prove in the first part. Now second part says, given is this, we need to prove this. Let's see how to prove this. Now in order to prove this, see, this is given to prove this. Now this is also set, this is also set. So what we are going to do here is, we will show that A minus B is a subset of phi, okay, so this is actually A intersection B dash, and this is another one is phi is a subset of A intersection B dash. So that's what we are going to show out here. Now empty set is a subset of any set. We know that, yes. So basically we will prove only this one here. Alright. So given is this, we will prove this because this is already there with us. Okay, so let me prove the second part. So given is A is a subset of B, isn't it? So in order to prove this, what we need to show is, okay, so I'm not going to do that way. So let me do this. Let me use one of the property which says, if you take intersection of the same set both side, that means I am taking intersection of B dash both side, then the sign remains the same. We know that. Yes. Okay. So we have A intersection B dash is a subset of. Now what is this? This means one of the properties says that this will be equals to phi, isn't it? Yes. So let me call this as equation 1, and we know that phi is already a subset of A intersection B dash, isn't it? So call this as equation 2. Okay, so using 1 and 2, using 1 and 2, what we can say is, we can say that A intersection B dash is equals to phi. Alright, so this means that A intersection B dash is what? It is A minus B, so A minus B equals to phi. So that's what we need to show here. Alright, so we have proved both the ways, that is 1 and 2. Pause the video and note it down. Okay, let me take the last question for the day, or last property. So the property says that here also we have got two signs, implies and implied by. So we need to prove that yes, so that's what we need to prove here. So let me take the first one. So first one says this is given, we need to prove this, right? So given is A is a subset of B. Alright, now to prove this, let me choose one random element from B dash. So let X belongs to B dash be arbitrarily chosen. Be arbitrarily chosen. Now what's the meaning of this? This means that X do not belong to B. Yes. Now, if X do not belong to bigger set, will this belong to A, the smaller set? No, right? So clearly this means X do not belong to A as well, since A is a subset of B. Alright. So if X do not belong to A, then X belongs to A dash, isn't it? See, X initially belonged to B dash, now it belongs to A dash. So therefore we have B dash is a subset of A dash. So this is already proved. Okay. So let's see the second part. So in the second part, given is B dash is a subset of A dash. Yes. So we need to prove this, and we'll choose one random element from A. So let Y belongs to A be arbitrarily chosen. Alright. Now if Y belongs to A, then Y will not belong to A dash, isn't it? Now if this Y do not belongs to this, then Y will it belong to B dash? No, right? Because B dash is a part of A dash. So clearly this means that Y do not belong to B dash as well, since B dash is a subset of A dash. Okay. So this means if Y do not belong to B dash, then Y belongs to B. Yes. Okay, so initially Y belonged to this, now this Y belongs to A. So this means that A is a subset of B. So we have finished all the properties. Yes. So pause the video and note it down. So today we'll do only this much. Thank you very much.